Hi, this is Mr. Ward, and I'm doing now a video on some of the transformation-related problems on the 2021 8th grade Math MCAS. So we're going to start with number 3, and then I'm going to hop over to numbers 13 and 17. So we have this rectangle. It's shown on the coordinate plane. That's the XY grid. It's M, N, P, Q. So there's your rectangle. And we want to know which of the following transformations of that rectangle would create an image that is similar but not congruent to the rectangle. So here's what you got to know about similar versus congruent. Similar, I'm going to start with congruent. Congruent, oh, got to move this down. Okay, congruent means all the measures are the same and the shape is the same. That means angles are the same and lengths are the same, and all in the same relative position. Okay, the type of transformations that create a congruent shape are rotations, translations, and reflections. So a rotation is a spin, keeps the same shape. It may have a different orientation. A translation is a slide horizontally right or left, up or down vertically, or perhaps combinations that make it diagonal, but it keeps the same orientation and shape and size. And a reflection is a mirror image that will be a different orientation, but the same shape and size. On the other hand, similar shapes have the same, I'm going to go out of there, same angle measurements in relative position, so they don't change their position relative to each other, and are scaled up or down proportionally when you think about their lengths. Okay, so a triangle might suddenly, all of it might have all its sides be 3/5 the size of the original triangle, but all the angles would be the same. Okay, so the type of transformation that makes similar figures is a dilation. Figures or shapes. Okay, so they make similar shapes if they are scaled up, scaled by a factor other than 1. Okay, so it's got to actually be enlarged or shrunk for it to be a dilation that makes a similar thing. I mean, technically speaking, a shape that is the same is similar, but we're looking for one that is similar but not congruent. So let's look at our options. A translation, 4 units up and 4 units right. Well, that's one of our rigid transformations that does not make it change its size or shape. This is going to be congruent, so that's right out. A 90-degree clockwise rotation, so going around the origin like that, followed by a reflection over the x-axis. That one is also going to retain its same shape and size. It'll be congruent. Now, this one's tricky. It says a dilation. You're thinking, oh my goodness, it's a dilation, so that's got to be the one. But then it says a scale factor of 1, which means nothing. It means that it did not change size at all. You multiplied all the sides by 1, so they all stayed the same. So nope, this one is congruent. It has a translation 5 units left. That keeps it congruent. Now, this reflection of the x-axis doesn't change anything about its congruency, but when we dilate by a scale factor of 2, we are doubling all the sizes while keeping the angles the same. D is our answer. All right, now I'm going to go over to 13 and 17. In 13, we're given this line segment UV on the coordinate plane, and we're told that there's a point W somewhere on the line segment. So I'm going to draw it somewhere on the line segment. Cool. It lies there. I didn't have to be precise because I don't know where it is. It just is on there. The coordinates x, y represent the point W. Okay. So line UV is going to get reflected over the y-axis. So there's your y-axis. We're going to get a mirror image across the y-axis, which means that all of the y values are going to stay the same, but all the x values are going to change signs. So let's see, that's at -6. So this will be at 6 of the x values change signs. So our reflection is going to look like that. Okay, it'll be V prime and U prime. That is our image of this. And somewhere on here is W prime. Okay, so what we want to know is what will the coordinates be for the image of point W? So well, over here, our coordinates were x, y. Okay, we don't know what x is and we don't know what y is. It's somewhere on there. What is it going to be over here? Well, y is going to stay the same. Y will stay the same because y, all of the y values just stayed the same elevation, but x is going to change sign. It's going to go from a negative, whatever x, the value for x is going to go from a negative to a positive, which means we're actually going to write negative x because a negative of a negative will be a positive. Over here, this has a negative value. Okay, this has a negative value over here. And over here, it has a positive value. A negative of a negative is a positive. So our answer is negative x, y. All right, I'm going to go to number 17 now. All right, so we've got this question. It has 3 parts, so be sure to label each part of your response, it tells you. So make sure you do that. Parallelogram EFGH was transformed to create an image parallelogram E prime, F prime, G prime, H prime. So there they are, as shown in the coordinate plane. So A, describe the transformation that was performed. Well, notice that E and F have the same relative position as do H and G and E. So it hasn't been rotated, it hasn't been reflected, and it all has the same size. So we're talking about a translation. This is a slide. So our transformation is A, okay, translated down. Let's see how far down. So G goes down 2 and then over to the right 1, 2, 3, 4. So down 2 and to the right 4. And that will be true for all points. Okay, and you could write a rule for this translation. X, y becomes x plus 4, because that's the horizontal translation, comma, y minus 2, because that's the vertical translation. And that would actually be a very thorough answer. So that would give you what you need. Now, is parallelogram EFGH congruent to it? Yes, it is. So B, yes, it is congruent because a translation is a rigid body transformation that keeps all the angle, angle, and here's the formal language of this, all the corresponding angle and side length measurements. Okay, so nothing changes size. It could change orientation, but a translation does not. It's a rigid body transformation, so it does not change any of these relative sizes of angles or any of the sizes of the sides. Now we're going to reflect E prime, F prime, G prime, H prime over the x-axis to create a new image. And then we're asked, will the parallelogram E prime, F prime, G prime, H prime be congruent to the original? In fact, yes, it will be, because this is a reflection. Okay. C, yes, it is a, so we can say a reflection is a rigid body transformation that preserves angle and side length measurements in relative position. Okay, since this is the result of two rigid body transformations, meaning that it keeps a rigid shape, does not change its shape or size. E double prime, F double prime, G double prime, H double prime will be congruent to E, F, G, H. All sides and angles will remain the same values and in the same relative positions. Okay, that was a very thorough answer that I gave you for this one, and hopefully that was helpful. So that was it for the transformations in this one, and I hope that helped. And I'm going to move on to taking a look at a couple of rational, irrational number questions and some other stuff.